There is no single solution for the climate crisis, but nuclear fusion can help a lot. Scientists at the Joint European Torus JET near Oxford, UK, announced that they had generated the highest ever sustained energy from fusing together atoms, more than doubling their own record from experiments performed in 1997. Nuclear power used today is created by a different process called fission, which relies on splitting rather than fusing atoms. But that process creates waste that can remain radioactive for tens of thousands of years. It is also potentially hazardous in the event of an accident. If researchers can harness nuclear fusion, the process that powers the sun, it promises to provide a near limitless source of clean energy. But so far, no experiment has generated more energy out than it puts in. JET's results do not change that, but they suggest that a follow-up fusion reactor project that uses the same technology and fuel mix, the ambitious $22 billion ITER, scheduled to begin fusion experiments in 2025, should eventually be able to achieve this goal. JET and ITER use magnetic fields to confine plasma, a superheated gas of hydrogen isotopes in the tokamak. Under heat and pressure, the hydrogen isotopes fuse into helium, releasing energy as neutrons. To break the energy record, JET used a tritium fuel mix, the same one that will power ITER, which is being built in southern France. Tritium is a rare and radioactive isotope of hydrogen that, when fusing with deuterium, produces many more neutrons than do deuterium reactions alone. That ramps up the energy output. But using this fuel required JET to undergo more than 2 years of renovation to prepare the machine for the onslaught. Tritium was last used by a tokamak fusion experiment when JET set the previous fusion energy record in 1997. In an experiment on 21st December 2021, JET's tokamak produced 59 megajoules of energy over a fusion pulse of 5 seconds, more than double the 21.7 megajoules released in 1997 over around 4 seconds. As pressures mount to address the effects of climate change through decarbonizing energy production, this success is a major step forward on fusion's roadmap as a safe, efficient, low-carbon means of tackling the global energy crisis.